Right?
Yes. Oh, I went live. Let's see.
We're here. It's live. It's happening. Here we go. We're live. Boo, 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 boo.
Awesome. I think we'll wait just a minute or two for people to trickle in.
Waiting for y'all to come in. I'm going to put out a tweet while we're waiting. But glad to have everyone here. Let's get going. Catch me. Usually I say catch me going live. I'm going to say catch me already live and join in on the build.
Oh, we have some people in the chat.
Web 2 to Web 3.
Hey, everyone. Thanks for joining. Hey. Good morning, Jim.
All right, my tweet is out. Send now.
That's the official kickoff.
Great. That is the actual thing. It is out.
Welcome, everyone. We're kicking off with Developer DAO's first ever hackathon workshop with Austin. Thank you so much for doing this for web3con, and I'll just pass it over to you.
Awesome. Thank you for having me. GM in the chat. GM, this is probably a private chat, huh? Let me GM to the, oh, I can't, wait. Nope. I have to like do something to get GM in the, I can see the YouTube chat, but I can't chat to it. Maybe I'll paste, if I ever have links, I'll paste to this chat. Okay, here we go. Here we go. Web 2 to Web 3 is what we're here to do. I'm assuming that you on the other end of this are a Web 2 developer and you're starting to tinker. Josh, what's up? I know some of these folks. You're starting to tinker with Web 3, and I'm here to kind of like help nudge you in and give you a license to learn within Web 3. And we're going to be talking specifically about Scaffold-ETH and some of those things, but use the tool that works best for you. And that's a kind of a key thing. So first of all, just like welcome GM, happy Monday. A great place to start is Ethereum.org. So Ethereum.org, and I'll paste it into the chat, but it probably won't. Oh, wait. There's the GMs in the comments. I don't know. Let's see what happens when I post something there. Ethereum.org is a great place to start. Things like learning the why of decentralization. Things like getting set up as a developer and getting your local stack going. Things like setting up a wallet and getting ETH for the first time. Go do those things. Chris West in the chat, GM, good to see you guys. All right. Oh, there we go. That's what I'm talking about. When I paste a link there, it shows up there. That's what I want. Hearts, Sarah. Thank you for making it happen. All right, here we go. So I am going to dive right in. But if you are a developer and you want to get to these resources, we are going to be looking at setting up your local environment today. A lot of great options. I would suggest using what works best for you. Today, we'll be talking about Scaffold-ETH, which combines Hard Hat. Oh no, the Hard Hat logo is broken. Sam. Hard Hat and Create React app, basically. So let's jump right into it. Scaffold-ETH. Let's paste that into the chat. So Scaffold-ETH is a dApp template. It's going to set you up with a freestanding dApp with kind of a smart contract as the back end and a React app as the front end. So it kind of just like helps you quickly build decentralized apps. Okay, but let's like back up from there just a little bit. What the heck is a decentralized app? Why are we building decentralized apps? What is this all about? And I think that's probably in the learn section. Decentralized finance. Is there just like a what is Ethereum? Yeah. Okay. Whoa. Okay. So Ethereum, right? The superpower here is it's a decentralized network that lets you quickly build on top of it. So if you wanted to build a decentralized application 5-10 years ago, you basically had to build the infrastructure yourself. You had to set up a set of nodes. All those nodes need to be communicating peer-to-peer. They have to have this incentive layer where people who are securing the network are getting paid to secure the network. There's a lot that is built already for you. And the power of Ethereum is smart contracts. We can build these simple smart contracts. We as the developer can write a small amount of code and deploy it on top of this big network. And the whole network is fine and it takes care of itself. We just run our little smart contracts on top of that. Okay. And we're going to kind of think of this in a lot of Web 2. I'm going to frame things in a lot of Web 2 ways. And the first thing is just like redundancy. Let's talk about, could I do like an ETH build here? Let's see if I do a sandbox.eth build. So let's talk about redundancy for a second. If you have like a little marker, yeah. So say you have a server and a bunch of people hit that server. Pretty soon you spin up some read replicas, right? And you split the read and the write, right? And you can handle a bigger load. Then if that falls over, you scale vertically and horizontally. So this is like that, but the redundancy is it's like huge. Basically, everyone who runs a node is going to have your app on it, and so it's going to look more like this. It's going to be this giant decentralized network, where a distributed network where everybody's basically communicating peer to peer. There's no central single point of failure. All of these nodes are talking peer to peer. Each one holds like 25 of its peers and it's communicating, right? So this network is built for us. We're going to be deploying on top of this network, but we also want to kind of understand like why this network is so powerful. And that the first thing is basically redundancy, like censorship resistance. If you own this node right here, you're talking to only your peers. You're talking to peers. And when you deploy a contract, basically you create a transaction and you send it out to all the other nodes, and everybody else respects that. And that becomes like a transaction on the network, right? So first of all, redundancy. This network is going to be hella redundant. Like when you deploy a contract, it's going to go to all the nodes all across the network. And when you want to update a value in your smart contract, it's a transaction and you pay the gas, and then everyone across the network respects your new change and everyone keeps a copy of that. So if we have a little smart contract with a counter in it and we deploy that, then everyone keeps track of your counter. And when you update your counter, it's expensive because everyone across the network has to update their copy of your counter. But what's really cool is if this whole section of the network gets smashed out somehow, we have some strange geopolitical stuff going on now, the rest of the network still remains and still keeps running. So it becomes this censorship resistance where if you deploy a smart contract correctly, not even you can stop it. And that's like a really interesting thing. Like no one can stop these. These are unstoppable apps. That's how redundant they are. Okay? And so why the heck would you want like that level of redundancy? Well, it comes down to trust and censorship resistance. So when we deploy a smart contract, the thing that you have to trust. So okay, next thing is trust. Let's talk about escrow. If Sarah and I wanted to switch, maybe I want to buy a pair of shoes from her and I give her $100 and she gives me the shoes, right? What if we don't trust each other? We know that if I hand her the money first, she's going to grab it and run. If she hands me the shoes first, I'm going to grab them and run. What we have to do is set up kind of an escrow in the middle where it's like a disinterested third party and we can kind of both trust the disinterested third party. And I give them the shoes, she gives them the money, they swap, and then we get our thing back, right? So that level of trust, that escrow, that man in the middle, in this case is the smart contract. The actual smart contract is the only thing you have to trust, and the network that it runs on, right? The protocol has to be safe and secure. But then what it comes down to when you're trusting a decentralized app, you're only trusting the code. The code is basically going to do exactly what you program it to do. And it should be a very simple, straightforward language that says, if Sarah puts in a pair of boots and if Austin puts in some cash, then it moves us in a state machine to this withdraw phase where now Austin can withdraw shoes and Sarah can withdraw cash. So that's kind of like the mental model here for these decentralized apps. So you've got censorship resistant, they're hella redundant, and the trust is minimized. There's a very like trust minimized network here where only you can paste and basically, or you can write the code. Okay, let's see, where are we? Programmable money, GM, critical. All right, cool. Looks like there's not, so far we've got the concepts pretty well. Okay, now going from Web 2 to Web 3, I think it's really good to talk about a cron job. So when you want to run a cron job in Web 2, you basically say, hey, every night I'm going to set up a script and it's going to roll my logs, right? And that runs every night at midnight. Let's say that you're building a decentralized finance protocol and you need to recalculate interest or compounding interest or something like that. Then you need it to run every night at midnight. If you set up a box that's talking to this giant, beautiful, decentralized network, it's not decentralized, right? That box is a single point of failure. So either that box can get attacked, that box can fall over. There's a lot of reasons why that box isn't decentralized. And hopefully like the picture that I'm painting here makes that clear. But what does it take to make a decentralized cron job? And the core of the answer here is that you basically need to incentivize folks and you need to write the rules correctly. So you would get in here to your smart contract and you'd write something that says something like, anyone can check in and you can only, out of anyone, there can only be one check-in every 24 hours. And then you incentivize folks to check into it. Whoever checks in gets paid $100 or something like that. The key that I'm trying to get to here is if you want to build a decentralized system, there are incentives and there's basically a censorship resistance. Anyone can connect to it. Anyone can run that job. We write the rules correctly so the job can only run every 24 hours, and we build an incentive into it that whoever runs it gets paid a few $100s. So that's what we're thinking about when we're talking about Web3 cron job. And hopefully this is starting to illuminate kind of what we're doing here and why we're doing it. So I'm going to dive into Scaffold-ETH, and we're going to look at a smart contract and building a smart contract app. Go ahead and shoot questions into the chat if you have any. So I'm just going to go to Scaffold-ETH. I think I pasted that all in already. Oh yeah, we've got Scaffold-ETH already. So I'm going to go to Scaffold-ETH and I'm just going to follow these instructions. I've cloned it down. I've already installed it. It takes like 10 minutes to do that part. So I've done that ahead of time. So the first thing I'm going to do is a yarn chain. And that's going to run our hard hat node. Basically, that sets us up with a local blockchain. And it's cheap and it's fast and it's free. So we can make all these transactions and it's gonna emulate as if we were talking to real world Ethereum, but it's also going to be local. Okay, so we've got our local chain up. Then we're going to do a yarn start, and that's going to bring up our front end. So kind of think of the blockchain as your back end, and we're going to have a React app as our front end. Okay, and then the third thing we're going to do is we're going to yarn deploy. And a yarn deploy takes our smart contract and it deploys it to our local chain. And then it takes what are called the artifacts and injects them into the front end so we can talk to them. So here we go. So let's do a yarn deploy and let's go look at our contract. So there it is. And there we go, compiled again. Let me make this a little smaller. Okay, so now this is the dev loop that I want folks to get into. You'll make a small change. I'm just going to add some exclamation points. You'll make a small change to your contract. You'll yarn deploy. And then hopefully we see that smart change, that quick change reflected in the front end. We're looking for some extra exclamation points here. And maybe I need to reload. There they are. Okay, and that's the dev loop you want to get into. Let me change this to hello D_D, right? And go ahead and deploy that. This dev loop right here, where you make some small changes to Solidity, you tinker around, and then you see the changes in the front end and you can poke at those. Okay, I'm going to grab a little money from the faucet here, and I'm just going to say hello world. So I'm actually going to make a call on my smart contract now. So I can do this set purpose, which calls the function set purpose using and basically makes a transaction to the smart contract, and it calls this function set purpose. And what that's basically doing is we have some arbitrary string we're keeping track of, and then we have a function that we've written to update that string and do one other critical cool thing, a console log. So let me do that again. Hey, send. And look at this. Let me make this a little bit bigger. Hopefully you guys can see this on your screen, but we have a console log where it shows some feedback there. Yep, see there, we can see it on the screen. I can basically get some feedback from my Solidity, and it sounds crazy, like console logs, that's how you're debugging. That's a big step up to what from what we used to be able to do. But sometimes you'll be in here in your smart contract writing some code, and you'll be like, what the heck is going on? This console log is very, very helpful. So just knowing that you have that there, and you can do a console log in your code to get some feedback about what's going on. Okay, awesome. Looks like we've got some no questions in the chat, just some YOLO noobery. Here we go. Okay, so now let's start writing our contract. Here's my method that I think will help you learn how to write Solidity. So if you go to Solidity by example, there are a bunch of great resources. I'll paste that into chat. So to learn how to write Solidity, you've got this dev loop where we can start writing some contracts. Start with primitives and data types. Paste in a few of these primitives and understand how they work. So a uint 8 versus a uint 256. You're using 8 bits versus 256 bits. Or an address. Notice how that address is just pasted right in here. Or a bool. You as a programmer, you know what a bool is. A bool can be true or false, right? Let's write a bool. Bool public is cool equals true. And let's deploy that, and let's make sure that is cool is true in our front end. And this is the dev loop I want you to be in. Trying new things. There we go. Is cool is set to true. Now, what if we make a function that's like not cool or something, right? And we'll make it public, and we'll let anyone call it, and we'll basically set is cool is not cool, right? Just basically swapping that bool for some reason. Just showing you that you can get into this dev loop where you can tinker with your smart contract and you can poke at it from the other end. And look at that. When we call this not cool function, it flips the bit for some reason. Okay, let's trash that. So this is what I want you to do. I want you to have Solidity by example up. And Scaffold-ETH kind of talks you through it, but there's a ton of different concepts you need to learn. First, understand the primitives and data types. Understand that you can grab your front end address here, and you can create some address public owner and set it equal to this, right? And paste that into your contract and deploy it and prove to yourself that it'll show up here. There it is. There's the owner now, right? And go through these concepts and understand them. Each one of these from Solidity by example kind of teach you how to do things. Now, let's write our first rule. One of the most powerful things you can do is program rules into your smart contract. So we're going to make a small rule here where we're going to require the message.sender, and that's basically the person who's calling the function, has to be equal to this arbitrary owner, or we'll fail, we'll kick them out of this function and we'll say not the owner. So technically, the way we've built this smart contract, we should require that the message.sender is the owner. So no one should be able to call set purpose except for this address. And let's go try it out. Let's go practice it and see if it works. Let's go poke at it. Let's go test our assumptions. So hello, we can test the happy path, right? This guy should be able to set it. Okay, so now we need a bad guy, and this will teach you about wallets in Scaffold-ETH. If I create a new incognito window and I open up localhost, I'm going to get a different address. So we kind of have like purple red guy, right? Purple red guy is going to be the bad guy, and we kind of have like teal red guy is the good guy. Whoops, that's the owner. So teal red guy is the owner, purple red guy is the bad guy. Okay, so the first thing I need to do is grab some funds from the faucet. You can also copy this address and paste it here to get funds from the faucet, or you can even open up this wallet and send yourself 10 grand from the faucet, right? So we have plenty of ETH. Now, what we want to do is try to set the purpose as this bad guy. I'm a bad guy, and then hit send. Hopefully we get a message that says not the owner. Okay, our rule worked. We set this require here, which is like an assert statement. And we said, if you're not the message dot, if the person accessing this is not the person that we have as the owner, kick them out and cause it to revert, and don't let them set the purpose. And there we go. No matter how many times we try, our attacker is unable to set the purpose. And these require statements are very, very important here. Let's change it up a little bit more. Right now, basically, we've written this thing so it has a purpose and only the owner can set the purpose. This is actually kind of pretty centralized. There's just like one owner that can set this stuff. If something goes wrong or this owner kind of does something bad, they're basically like, it's not that cool. What we need to think of these smart contracts like vending machines. Anyone can get to them and anyone can access them. And we set the rules in which we want basically the economy around it to work. So let's get in here. Sorry, I'm not doing a very good job watching how to open incognitos. You can open an incognito. I think it's like Shift Command New or something. Incognito will just give you a new address. I'm not seeing any particular questions. Okay, let's get into this. So I want to write another rule, and I want to make this thing less like, basically right now it's like an attestation machine. Only the owner can get in and set the purpose. What we want to do is make this thing like a vending machine. Anybody can get to it. So I'm going to change this function to be payable. And if you don't know what payable functions are, go to Solidity by example and learn about payable functions. And copy and paste this example in here and figure out how it works and learn through it by copy and pasting and kind of iterating. So I'm going to make it payable, and then I'm going to set up a different require statement. I'm going to require that the message, instead of message.sender, we're going to say message.value. I'm going to require that someone sends in at least, greater than or equal to 0.001 Ether, okay? And then I'm going to say not enough. So I just changed this from being only one person can get in and it's this person to now anyone can access this function, but they have to pay for it each time. And let's ship that thing to production and let's try it. Let's see if it works. Now, what should happen here is our front end, should detect that now we're taking in value. And you can see that you want to charge folks to get in here. Now, if I say hello world and I don't send any value in, I'm going to get not enough, right? It's going to tell me I don't have enough money. So if I do a 0.001, now we haven't gone Ether to Way here, but I'm going to convert, this is in Ether right now. I'm going to convert this to Way, and we'll get into that in a second, but let's send this. There we go. I was able to pay money to set the purpose. Hey, send. Now I'm paying money. You'll see my money is going down and the contract is starting to receive value. Now this is pretty cool, right? It really is kind of like a vending machine. This machine, this contract, this smart contract is doing exactly what it's programmed to do. Anyone can get to it. And if they pay the right amount of money, they can set the purpose. And now this contract is starting to collect value. So we probably should have built some kind of withdraw function in here, right? This money is basically stuck in this contract forever. Good thing it's on localhost. What you would do is you would set up a withdraw function. You would say only owner can withdraw. And then the owner could get in here and maybe clean out the vending machine, clean out the money from the vending machine, right? Okay. The superpower of Ethereum is it allows you, the coder, to write super simple, straightforward syntax and deploy it to this network. And you're basically making these vending machines that anyone can get to and access. So you as the developer can quickly innovate and build decentralized apps on top of this platform. And it's actually super easy. Let me add to it. Of course, building a secure smart contract system is incredibly hard, and there are very few people in the whole world that can do it. But You're just getting started, and this is getting you one step closer to that. And you can be that person someday. It starts here, though. It starts with tinkering with Solidity and testing your assumptions. So let me just show you how we could change this. We had an attestation machine, and then we turned it into a vending machine that anybody could pay for value. What I want to do, though, is I want to add a price curve to it. So I'm going to set up a public price function. Okay, and I'm going to set that equal 2.001 Ether. We haven't got in to talk about Ether versus Way yet, and we'll get to that in a second. But what I want to show is that we can quickly write some code and we can create new financial mechanisms around that code. So basically, this is the same thing. There's a price, and we're making sure that people set at least that price. What I'm going to do here, I'm going to add one more line to that, and I'm going to say, if we get this far, I'm going to say price equals price times 101 divided by 100. Okay, and I'm going to put some parentheses around this so we can tell what the order of operations is. So what I'm doing now is I set the price. I let anyone call this function. I let anyone set the purpose. But every time someone sets the purpose, the price goes up 1%. So we just created a price curve where this is going to go up 1%. By adding a single line of code here. Let me go deploy that. And now we should get a new smart contract in our front end. It should be empty, and we should be able to set the purpose. Anyone should set the purpose, right? Let's go back to our attacker, and let's go to localhost. Remember, this is an adversarial network, and it's trust minimized. Let's go back and think of blue guy as the bad guy now. They're all bad guys. Everyone's a bad guy, and they still need to be able to use your vending machine without draining it, right? So you need to be able to trust this code, but now we want the bad guy to be able to get in here and set the purpose. So as a bad guy, whatever, anyone can get in here and say, hello world, as long as they pay the price. And we're going to pay a little bit of ETH, and we're going to hit send. But watch this price when I do this. Boop, the price just went up 1%. Now I need to pay this price, right? Hello 2. And when I send that, boop, it goes up another 1%. So we've created a price curve by just adding one extra line of Solidity. And this really leans into why Ethereum is so powerful. So you can make small little changes here and create new financial mechanisms on top of it. Okay, can we inherit in this example? If you want to see inheritance, we could do something like this. Bring in ownable, say contract is ownable, and now it's ownable. And instead of saying require this, you could do something like only owner. And that's how inheritance works, basically bringing in the Open Zeppelin contracts. I'm not going to do that here, but that's just a quick example of how you could bring in inheritance. Okay, so we're about done. Now this is let's say we've tinkered around, we've played around with our system, we've created this cool price curve. Now, how do we deploy this thing to production? How do we make this thing into a production level app? Well, right now we're only working on it locally, so we need to deploy to a public network. So I'm going to yarn generate. I'm going to create a local mnemonic, and then I'm going to fund it. So yarn account, I'm going to fund it with a burner wallet on Covan. So I'm just going to pick a random test network called Covan. What I really want to show is you can go from 0 to 1 really quickly. So I'm going to use a burner wallet, a punk wallet built with Scaffold-ETH. Yes. Oh no, I just canceled it. I'm not going to use a punk wallet. I'm just going to copy this, and I'm going to use my MetaMask, and we'll switch it over to Covan. Here we go. We're going to run a little bit long here. We're going to run past the 30-minute point. I hope that's okay. Just maybe by 5 or 10 minutes here. I'm going to send just a little bit of Covan to this deployer address, and we're going to put this thing out on a live network. Let's see, 0.1. Make sure we're on Covan, hit send. Okay, so I've created a local deployer account. I've funded that local deployer. We've tinkered around on localhost long enough. Let's take this thing to production, right? Let's ship it. So I'm going to say yarn deploy, and I'm going to add -- network Covan. All right, here we go. Public network, ship it. Let's do this. Hopefully this works. We're going to deploy this thing to a public network, and then I'm going to set it up so you at home could access this app. Basically, we went from tinkering at localhost to a decentralized app that anyone can get to, that's backed by a smart contract on a public network. There we go. So our contract is deployed, but our app hasn't live updated. There's one other thing you need to do in Scaffold-ETH, and I need to jump to the React app side. So this is over on the front end. First React app edit we're going to make. You'll notice all these handy hooks and wonderful things you can do in here. It's a little busy. You'll have to get in here if you're a React person and kind of learn some more. But what I'm going to do here is just switch this to Kovan. So the entire app now is going to shift and turn into a Kovan app, and it's going to be pointed at the smart contract that we just deployed to Kovan, hopefully. There we go. Now we're on Kovan, and here is our app out on Kovan, okay? So we've been using burner wallets so far, but what we need to do now is we need to go ahead and connect our MetaMask, right? There we go. Now I have my MetaMask connected. Notice the nice ENS resolution, the nice blocky preview. All of these handy components will come off the shelf for you, thanks to Scaffold-ETH. But let's go set the purpose. Hello world. Okay, and let's go ahead and pay 0.00001 ETH. And there we go. Now we get a nice MetaMask prompt. Now it says, Kovan, do you want to pay this? Right now, this is familiar to you as a user. Now I'm using MetaMask. Now we have this nice block native. And there we go. We updated it. And if I reload, there we go. Hello world. And there's $2.81 in this contract now. And now we're on a public network and it's locked up there forever because I don't have a withdraw function. Last little piece here I want to do is a yarn build. And that's going to build our static app. There was one little gotcha that we haven't gone through yet. And it's this stuff here, kind of the ETH to way. Notice we did 0.001 Ether. We did a decimal, right? So the EVM, back here is my ETH2 node in my video. The EVM is meant to be simple. The more simple the EVM is, the easier it is to run, the more decentralized the network is. So we all have a little virtual machine that runs on our node that processes these smart contracts. And what we have is this smart contract has this nice price function in here where it goes up 1%. But I can't just say price times 1%. There's no decimals, and it's kind of tricky. So the EVM works with no decimals. It doesn't do floating point math. So the trick is when you go from 0.001, when you go to talk to the machines, when you go to talk to the EVM, you have to multiply it times 10 to the 18. Right? And that's into way. So there's this ETH versus way kind of thing where everything with the smart contracts is in way. Man, which one of these do we even want to look at? So one Ether is actually this many way, right? So if I have 100 Ether, or I can even have a decimal point, and that's where the decimal point comes in, is you can have a decimal in Ether, but it's actually in way. And you'll get into that later, but just being aware of it. Obviously, if you were building a production level app, you wouldn't have your user have to put in 0.001 and then multiply it times 10 to the 18. I'm having you as the developer do that, so it's clear to you how that works. But eventually you'll build an app where someone can set the purpose and hit go, and they don't have to worry about ETH first way. But when you're in debug mode, when you're tinkering, you'll still have to understand ETH first way. So we talked about redundancy, we talked about trust, we talked about decentralization, we've talked about cron jobs, we've talked about ETH first way, we've tinkered with a smart contract, and then we've built and deployed that thing live with one more command here. I can do yarn surge. What's this thing going to be? Oh, that was a fun one. This is going to be a price curve purpose or something like that, right? So I've built my static app that contains all of the front end and the reference to my smart contracts. And now I've just yarn surged, I've deployed it live. So now anyone can follow this. Oh, let's do https:// anyone can follow this link that will dump into chat here, and you can have access to the app that I just built. So in 30 minutes, that was more like 20 minutes, but with the early, in 20 minutes, you can pull down Scaffold-ETH, tinker with a smart contract, deploy to a live network, build and deploy an app, and then anyone can get in here and pay Covan. Let's go ahead and connect our wallet, can pay Covan to update the purpose. And each time someone updates, oh, this is so ugly. Each time someone updates the purpose, oh man, and then I didn't hit it. Come on, MetaMask, come on. What are we doing here, MetaMask? You're killing me. Okay, and then anyone can pay to use this thing. So we basically went from 0 to 1 with a fully, it's not, you can imagine that the front end is not fully decentralized. It's on Surge. You would need to put it on IPFS. You would need to make it forkable and available for others. But in essence, we went from 0 to 1 here in terms of we tinkered with a smart contract. We deployed it locally. We got it working the way we wanted. Then we deployed it up to a test network, which is exactly the same as mainnet ETH, except for we're not paying for it. We could have easily YOLO'd this thing to mainnet. Then we deployed the app that anyone can get to. And if I say, hey, 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 on this live domain, like we should be able to pay this amount to set this, and we should make a live transaction on Covan on a live site. And there it is. Like we're able to go from 0 to 1 with Scaffold-ETH. And that's what I want to show off today, is like give you the license to start learning, give you the mental model of kind of going from Web 2 to Web 3. This, like Scaffold-ETH, this should be where you can go to do that. Go to Scaffold-ETH and learn that stuff. Okay, so now let me finish up. We'll do a little the update cycle. So in this case, this smart contract is not upgradable. It's very immutable. It's going to live right there, probably longer than I live, and no one's going to be able to stop it, right? There are upgrade patterns, but then that adds immutability. If you have the ability to upgrade a contract and it's just some account that can upgrade the contract, then it's not decentralized, right? Maybe you set up a multi-sig that allows you to vote to upgrade the contract. There's a lot of like different patterns that you'll find. Go look up Open Zeppelin's contract upgradable pattern and you'll find one there. So Scaffold-ETH is your spot. It's your spot to go learn and tinker, right? You're going to use Solidity by example. You're going to paste stuff into the smart contract. You're going to tinker around, okay? Now, once you've done that, you can go from 0 to 1. You can make some apps. You can tinker around. What I want to show off is speed run Ethereum. So this is, if you are a Web 2 developer or you know Web 2 developers that are looking to get into Web 3, this is basically what we've been talking about today, but in a nice condensed format. It says, go grab Scaffold-ETH, go through each one of these global units, primitives, mapping, structs, modifiers, events, inheritance, how to send ETH, how payable fallback functions work. Get that stuff solid. Just go tinker with it. If you're a good developer, you'll learn it quickly. It's easy syntax. It's easy to get. And then start taking on these challenges. Test out your knowledge. Go through building. This is basically following instructions, to be honest. Challenge 0 just gets you with the environment set up, but it'll help you deploy your own NFT. And you can fork that and take that and run with it and go deploy an NFT, but keep going. The next thing is a decentralized staking app. It really leans into the superpower of Ethereum, and that's kind of the fact that you as a builder can quickly write these rules, and then multiple adversarial parties can coordinate financially using your smart contract, and they can't grief each other and they can't steal from each other. You learn about how a smart contract is kind of like a state machine, and it goes from a deposit state to a withdraw state, or a deposit state to a successful state. Once those adversarial parties either all stake together and it's a successful move, or they don't get enough stake in and they need to withdraw their funds, no one can steal, no one can grieve. Then you get to a token vendor, learning how to deploy a token, learning how to deploy a vendor that will sell that token, learning about ERC20s, learning about the approve pattern in particular, learning about contract to contract interaction. Then things start to open up. You'll get into cohorts where we have Telegram groups with folks that are teaching you as they build themselves how to build a multi-sig wallet, how to build a DEX. Now, decentralized exchange is so cool. You have reserves stored in the contract, and it's completely decentralized, and anyone can get in and swap token to ETH or ETH to token, and it all just comes down to this price function that's looking at reserves. those people that provide that liquidity, that provide those reserves, get an LP token, and that LP token slowly gains value as people swap because there's a fee that's built into it. It sounds complicated, but it's actually very simple and straightforward. You can get in and learn how the price function works, and you can get in and learn with other folks how to build a DEX. And then the last challenge is building, well, the last challenge so far is building an SVG NFT. But the point I want to make here is that you will build your Web3 profile. Get in here, take on these challenges, learn how to build, get into a routine of just like shipping garbage. Don't actually ship garbage, but ship things. Like, they don't have to be perfect. You can ship things to a test network. You can have your friends play with the test network. Get in a routine of, I want to go tinker with dynamic SVGs that change every hour. Go build something simple, ship it to Kovan, show it off on Twitter, and repeat that process. And go build up your Web3 portfolio over at Speedrun Ethereum and go through those challenges. And you'll end up finding a bunch of builders like you that are also building cool things. And from there, who knows where we'll go. I will hint that the Build Guild is sort of an incentivization layer I built on top of all this stuff, where I'm funding a whole bunch of builders to build generic components, prototypes, tutorials on top of Ethereum using Scaffold-ETH. And if we even go look at, sorry, I'm like way over time and super windy here. If you even go look at the Scaffold-ETH org, and we go to Scaffold-ETH examples, let me paste this into the chat too. Here we have a ton of examples for you to branch. If you don't want to start with master Scaffold-ETH, you want to get dangerously close to having a prototype of, I don't know, a wallet or token multi-drop, right? Who doesn't need to build a token multi-drop at some point? Or how about a Circom starter kit? Let's say you're about to build a game on blockchain. You're probably going to use ZK or some kind of commit reveal scheme. So you get randomness. So you get a hidden world, right? On a public deterministic blockchain, it's kind of hard to build games that are like cool, right? You'll probably want to use this Circon starter kit right here. So let me go ahead and just paste in the Scaffold-ETH examples. Actually, let me even paste in this cool branches view where we look at what's active. Here we go. Here, what is it? 266 different examples of things that someone has taken from Scaffold-ETH. Chainlink VRF. Someone said Chainlink VRF. Watch this. Let's go to Scaffold-ETH examples. We want to learn about VRF. Someone teach me VRF. What do you got? Look at that. There's Chainlink VRF and there's an NFT VRF. One of these branches, look at that. There's even a video of me shilling it. So here is how you would use Chainlink VRF built into an NFT on Scaffold-ETH. It's a nice forkable repo. There's a video there. Everything is going to be in the same place. Once you get used to Scaffold-ETH once, all of these other things translate and everything is in the same place. So it's creating this like really composable environment where lots of people can build lots of things, and we see, 1,000 Scaffold-ETHs bloom. So okay, now I think I've done my full shill. We are over time by 13 minutes. I hope y'all out there are enjoying this. I'm watching the chat. I haven't seen any major questions, but I have my Twitter is open. If you go to, here's me on Twitter. This is the guy. Let me paste this in here. DMs are open. Feel free to DM me any questions you have that you wanted to get answered today and didn't get answered. I'm at Austin Griffith, and I'll paste that in here. So hit me up with questions. Also, just YOLO them into the chat for a little bit. I'll hang around for another like 6 minutes or 5 minutes or so. If anybody has any questions, you can YOLO them anonymously now if you have them. I'm watching the YouTube chat. Let's see, we covered a lot of stuff, but if you guys feel like you have more questions, please get into the chat. If you haven't yet, there's there's all my Twitter chats on YouTube. It's fine. I don't do anything that private. So yeah, YOLO some questions to me either on Twitter or shoot them into the chat now. Yeah, open to questions now. I think that was the speed run. I think I covered most things. Moonshot is another shout out to give. Basically, like kind of after Build Guild's kind of putting these widgets together, like these little kind of components. Moonshot is looking at like, how can we take those things to, you know, products, and what do DAOs need? What DAO tools do DAOs need? And how can we build those primitives with Scaffold-ETH first? And then how can I make the owner address private? So nothing is private on a public blockchain. It just doesn't work that way. You can't, you could make it so someone couldn't see it, but they can still in a way see it. So this is a public deterministic blockchain. Nothing is private. You can do things like commit reveal. Go ahead and Google commit reveal, and you'll see that like you can make attestations on chain for a thing without showing that thing, but then later you have to reveal that thing. GM to Natter man in the chat. Hearts, hearts, hearts. Yeah. Secret network. Yeah, okay. I don't, it's a public deterministic blockchain. If you're using a private blockchain, you're doing it wrong. What else? Any other questions? How about a really good place to get started that isn't anything I've talked about now? A really good challenge for you as a developer, just to go get a little bit of context. Go write a node script that uses ethers.js, just ethers.js. Go npm init in a folder, make a plain script that uses ethers.js, and learn about providers, learn about signers, and learn about wallets and how those things work together. Basically, generate a wallet locally and get the address for it, and then have your script watching the balance of that address. And anytime someone sends some money to that address, forward it on to your address. And then keep that script running, and then try sending some ETH to it and see if that ETH forwards along. So super, super lightweight thing, other than just like, if there's one thing that you get from this, go speedrun Ethereum, go try Scaffold-ETH. But if you'd like a completely Austin-less shill of something you should get into, check out ethers.js and just make a simple ethers.js script that has a wallet that checks a balance, that sends some funds. That'll get you some exposure to this stuff without any overhead at all. Okay, I think that's about it. Speedrun Ethereum is the spot to go. Open still to questions. Can I make variables private? Yeah, you can make variables private, but they're not really private, right? Basically, it means a private variable means other, like, you can't read from it, and other contracts that inherit it can't set that value. But there's no such thing as private on a public deterministic blockchain, unless you're using some ZK tech and it's like a commit reveal type thing where it's hidden until it's revealed, sort of thing. There we go. Check out speedrunethereum.com. Thanks for doubling down on that. Anybody else? Any other questions? Go get, oh, Brownie's dope too. Like I said earlier, like if you go to ethereum.org and there's, you know, other tools here, use the tool. I think Brownie is here. Use the tool. Yep, there it is. Use the tool that gets the job done for you. Use what you want to use. Use the tool that helps you build the thing. Now, I showed today that you can build the thing in like 20 minutes with Scaffold-ETH. So there's a lot, like there is a fast way to do this, but it's up to you. You use what helps you get things done. Blind spots for new developers. That's a great question. So we talked about a lot of them already, right? The ETH versus Way thing, the EVM kind of no floating point math. The storage is very expensive because it's hella redundant. The idea of a cron job, you can't just like have a process checking in. That's not actually decentralized. You need to build an incentive-based network to get people to check in. So to think of the blind spots there, redundancy, trust, understand why Ethereum is powerful, but understand it's also super expensive. Like you're deploying to an L1 that costs $1,000 to put a smart contract there, and you have to build the incentives in right so people get paid to do the things you need them to do. Kind of like on top of that, though, there's some really neat things happening this year, like L2 Summer, L222 is happening. Optimism, Arbitrum, ZK Sync, Polygon. there are these networks where you can deploy. And by the way, like everything we've done here translates to all those networks. Where I said Kovan, we could have replaced that with Optimism. We could have put a little OE in that wallet, and we could have deployed to Optimism exactly the same way. So all of this stuff deploys to these other networks, but there's going to be cheap and fast with backed by L1 security. So these tools are going to work to build cool games out on those L2s, and it's going to be less expensive. So some of those gotchas are even kind of going away, right? Same thing with like the energy usage, right? Right now, this bad boy uses very little energy, right? When ETH2 comes along, when the merge comes along, not ETH2, when the merge comes along, this is going to be my Ethereum miner right here, right? It's going to be validating blocks, and it's going to be using a tiny little bit of energy instead of crunching and crunching and crunching. Where can non-developers connect? Well, I mean, you can connect with me on Twitter, but my target audience is developers. I try to get into like the developer thing. If you want to connect, if you're a non-developer, you're in the right place. Go talk to DAOs. Go figure out what DAOs need. I think I saw someone say this the other day. In Web3, if you want to get in and do a job in Web3, the best way to do that is to get in and start doing the job. Like if you see a need for something, maybe it's communication, it's connecting people, maybe it's marketing, maybe it's design. Web3 needs all of those things. And also, like as you're seeing this, there's a lot of Web2 that is in Web3, right? There's a lot of overlap. A lot of your skills in Web2, especially like DevOps, will translate into Web3. Just get in, go to those DAOs, find things that people need and do those jobs, and pretty soon you'll be right in. Yes, join the hackathon. web3con.dev/hackathon. Hearts to Developer DAO. Hearts to Natterman. Hearts to Sarah for putting this together. If anybody has any questions, hit me up. I'm live and open to them on Twitter. I'm at Austin Griffith on Twitter. I think we've almost covered everything. If you still have questions, yes, contribute. That's exactly right. If you want to get in, just get in and start contributing. If anybody has any last questions, maybe just hit me up on Twitter. I think we're gonna call it good. So yeah. To recap, go to Speedrun Ethereum, get Scaffold-ETH, learn the basics, go through the challenges, and from there you'll have everything you need to start tinkering and start shipping things more regularly. Thank you. Hearts. Go build decentralized apps. Go do it. Use this as your push. Go get it right now and start tinkering. Go put a smart contract out on a test network. Just prove that you can do it. If you haven't yet, go get a wallet. Go get MetaMask on your machine. Go get Rainbow on your phone. Learn how to wallet connect in. Send ETH around. Send tokens around. Swap ETH to DAI. Go register an ENS name. If you out there, if you don't have .eth, if you don't have a .eth name, go to ENS domains and get it done. If you're a developer and you're building stuff and you don't have an ENS, reach out to me. I will sponsor it. You got to show me that you can like build some stuff on Speedrun Ethereum. But there we go, ENS domains. We are way over time. Hearts to everybody. Thank you. My DMs are open. Keep building. Keep being awesome. Yeah, thank you, Natter, for bringing us together. Thank you, Developer DAO, for being a great place for developers to land. Hearts. All right. Thank you. I don't know how to say goodbye or how it works, but yeah, thank you, everyone.